So I have hi, I'm Phyllis Marbach, Assistant Director for Transformational Enablers and retired. I have a question about for the unmanned air systems talk. You talked about we needed to establish the means for transportation management of the operators of those vehicles or unmanned air systems. How do you propose they communicate with each other? Because, you know, what I've seen is it's just random people here and there, you know, flying their drones.
Yep, that's a great question. So the system being established, this UTM system, UAS traffic management, establishes the different rules for how folks have to communicate with each other based on where they're operating. So there's less requirement if you might just be operating, say, a drone within your visual line in your backyard. But if you're going to then look at from the public safety perspective, potentially you want to fly your drone all the way around town to be able to set that up and say respond to 911 calls, then there are more regulations both with registering with the FAA, with having a remote ID, which is like a digital license plate for your UAS available, so that those can be tracked and accounted for. And then also some of these other requirements, I think when I glossed over, there are a lot of regulations but for setting up the system, but other things that might go into that could be areas like having to geofence around where you'll be flying so that you ensure that you stay within your operational range when you're beyond visual line of sight. So those are a few of them that, but it's a great question. And I think it's one that's still being continually tested and piloted by the FAA and NASA and different providers.
Online, you guys have any questions? If you want to come off of mute and ask any questions you might have. Oh, sorry. Got that. If you guys online, if you got questions and you want to come offline and come off mute, sorry. And then of course, ask your question if you have any. Otherwise, I'm going to start peppering him with audience, with us. Go ahead and go.
Trying to contribute here. So question again on the UAS, and then I have another one for Perry if nobody else has any. So it looked like you had some slides that had the beginnings of model diagrams on there. I was curious, have you actually done any modeling of that whole domain that you talked about? And if you haven't, because I know that can be challenging with, you know, like getting paid to do it. I'm curious, with your knowledge of that whole domain, what would be a part of that you would start modeling for, like, what purpose would you be trying to address by using modeling to better understand and manage that domain?
Okay. Yeah, great question. So no, we've established the foundation and sort of the approaches we would take, but we haven't started building out explicitly the model. We're working with different facilities within, like, we're located in Arlington, Virginia. So we're working with the state of Virginia and a lot of the different entities there who are looking at building these out. And we've discussed the advantages that a model could have to allow the entire system to be integrated and to be able to adapt to change more readily. But from our perspective and where we're coming from on this, the first place that we've started looking through all these, when we've gone to the public safety space or the state and local space, is really getting in on and working with them on the key use cases and needs from those applications to be able to set the foundation of that. Because I think in our experience, it's the stakeholder and mission aspect that sets you up for failure or sets you up for success instead of failure by understanding those key needs. I think got another one for.
Was it for Perry, different presenter? You started talking at one point about having the development team very separated from the product team, which is common, and how that, so it sounded, I'm just curiosity question. It sounded to me like you were talking about DevOps. Is that essentially what you were talking about, or is it something a little bit different than DevOps?
A little bit different. It's all tied into one big idea, I think, but I was talking specifically about product management teams. So the people that speak to the customers, that write the product spec and talk about product delivery, and the engineering teams, who are the actual teams that write the code for the product itself. Those teams started out as two separate teams with two separate worlds that had to communicate and collaborate, which was actually fighting. And now are starting to merge into one holistic team, but DevOps is a critical part of that too.
You ready to go? Let's take
Yeah,
one from
I'm
let's
ready.
take
I
one
have
from
a
the
question
top.
for Parry.
Go ahead.
You mentioned in the last part of your presentation about continuous integration and continuous deployment. Now, these terms are, let's say, quite common in software, but what are your thoughts when it comes down to combined software and hardware and or even systems?
Yeah. So you're asking, is it possible to extend the paradigm in software to hardware?
Yes, that's exactly what I'm asking.
Okay, great. Yes, I believe it has to be true for the future to happen, is I guess my philosophical ideological view on this. If you look forward, not 10 years or 20 years, but you look forward 100 or 200 years from now, we're not going to be talking about 10 parts or 1,000 parts or 1,000,000 parts in the BOM. We're going to be speaking about 100 million parts in the BOM. If you tried to do the verification and validation cycles for that, that's more horsepower than all of humanity together. So it's impossible for the future to happen without that paradigm applied to hardware. Now, exactly what that looks like is still unclear and being formed. We have a view, we're building a specific solution to that. But I think the core element of this comes down to two things. The first is integration. Can you get these different teams and these different models and these different worlds to collide and integrate better together? And two has to be automation, which is once you have this integrated view of the world, can you leverage software's automation to be able to automate the tens of thousands of months you'd need to physically verify every single model, every single element, every single requirement.
Right. Okay. Thanks.
Thanks.
So while you've got the microphone, Perry, it says, I'll read it out loud for you. So based on your experience and lessons learned, what's your take? What's your take on existing Mbsc methodologies and approaches? Any changes you'd make?
Such a big question. So many ideas. I think fundamentally, this goes back to the Hamming quote of working on, are you building a good solution to the wrong problem, or are you building an inadequate solution to the right problem? I don't fundamentally think the problem is around Mbsc, SysML, or modeling tools. The fundamental problem is around whether the world of systems engineering and mechanical engineering, electrical engineering, aero engineering are one team, or are two different teams that are working against each other, in short. Because you see that again and again and again. I think fundamentally, if you have SysML, or you have Excel, or you have an ugly database, or you have stuff on pen and paper, it doesn't make a difference. The Blackbird, in my mind, is one of the greatest examples of systems engineering and systems design ever made. And that was done on pen and paper. I think fundamentally this comes down to, are we bridging the worlds of systems engineering and the other engineering functions?
This is a Tony online. I have a comment I'd like to piggyback on, if I may.
Yeah, please.
Yeah. So Perry, I really like the slide on T-shaped expertise because I think so. Even going broader, yet last year there was a problem in Florida where an operator used a systems mindset to prevent leaching of poisonous chemicals into the water supply near Tampa Bay, near Tampa. So I think not just everyone, even guys who are operating critical infrastructure, and I'm the guy that did that talk, needs to have that mindset that you advocated. So I commend you for that, and I really appreciate you including that in your talk. Thank you.
Thanks.
I guess that might be one of the themes that came through from today, not like it was coordinated at all, but the fact that how do you get that systems mindset installed in people so that they have a record. I notice, of course, with my teenage son, he's gathering a system mindset the more experience he has. The problem is all that experience does two things. One, of course, we've had running conversations. It takes a long time to get that experience, and we can't afford all that time to get that experience. And then once they gain all the experience, then they leave, and the issues come back. We've lost all that experience, right? So the answer is a Vulcan mind meld or something like that, right, to pull this off. Hopefully that came through and I think it kind of hopefully came through in this conversation we've had today and the presentations and otherwise, is the fact that you notice it's not about tools, although tools help if they're simple enough and so forth, but it's about a mindset. So I was curious about our good friend Roger Everett, right? Okay. You guys all knew about the S-curves before he pointed that out to you, right? You just didn't know where it came from? That it was agricultural? I know you guys know, but I'm talking about the audience here. Okay. And of course, this has been picked up. This has been picked up, of course, by people like McKinsey and Company. You guys, if you read the series on crossing the chasm, well, it has to do with tech companies, why they make it. Sometimes they don't, is they don't get across the break between the early adopters and the early majority, right? Stuff like that. So now that you've digested the entire book, right? And I noticed what you're going to do for further investigation, but I'm sure all of us would be interested in what do you think is the next thing we should be doing to help people get, oh, we're going to get another microphone here for you. What do you think is the next thing we should be focused on, given Everett Rogers' perspective on this?
Well, I mean, I threw out quite a few options there. I liked the very first presentation. I can't remember who it was, but as I mentioned in my presentation, it's all about context. So I, at my employer, have been told, hey, you need to go help these people do Mbsc. And so I come in there and say, okay, what do you want to do? And they're like, we want to do Mbsc. And that's obviously not enough. And everyone here in this room, everyone who's spent enough time with Mbsc knows it's not just something you do, but you have to have a question you want to answer, a problem you want to solve. And so I think the biggest thing is stop, whenever we hear someone say, okay, how do we do Mbsc? Just stop the conversation, right? Just stop it right there and say, first of all, what do you want to do? And that's really like fundamentally what systems engineering is about, right? We want to be solution agnostic for as long as possible. We want to identify the stakeholder needs, like, evaluate alternatives. And if we come in saying, well, we're going to do Mbsc, well, we've just hijacked that whole process. So whenever we're investigating it, moving towards an Mbsc direction as an organization, I think we stop and provide the context of what problem are we trying to solve so that we can actually have a good path forward.
There's some good advice on just stop the conversation right there, right?
Yeah.
So one of the interesting things that we notice about these, given the amount of effort that have gone into the tools, get into work in organizations and so forth and so on, they have this tendency to invoke cult-like followings. Mm-hmm. Okay. And so when you start to talk about a cult, then it's not a casual conversation. Okay. So rather than fight that, you guys saw when we had the maturity matrix that we showed you earlier from my presentation this morning is the fact that if we come into an organization and we start drawing a line of where you are, and what you need to do is, I think the advice we got from changing the context, you need to get the organization that you're inside of or we're working with a bigger picture about what we're trying to achieve here with model-based systems engineering. It isn't a tool about requirements. It's not a tool about performance. It's a combination of things. And so you need to get them a bigger picture. So we found that this matrix that we talked to you guys about earlier is a way to be able to just disrupt all that conversation. You don't have that conversation anymore because we're after this journey. It's a journey, right?
Yeah.
It's a journey from where we are to where we want to be. It's not about a tool. Go ahead.
Yeah.
You're gonna add
well,
something.
and your matrix is, more digestible than the model-based capability matrix, right? Like the 42 points, but they both serve the same purpose to figure out where you're at. And then as an organization, figure out where you want to go, like set a roadmap. Because again, you're not just going to go out and do Mbsc. It's like, we want to improve our requirements management. We want to improve traceability. Like any one of those points, you can hone in on and decide where you want to be in each of those things, because there may be some aspects that's not important to your organization or to your program, things that you don't care about. And so why would you waste your energy and credibility fighting people on things that really don't matter to your organization? And it allows you to really hone in on those things that do matter.
Yeah. Okay. There's a question coming in for you, Stephen.
All right.
Here's the question. Stephen, modeling UAS, what kinds of changes does Mbsc help you with, and how does it rely on having access to the same patterns for UAS systems? I need to repeat that for you.
No. So the way that we approach that is that looking at it from a public safety perspective, maybe either the jurisdiction or multiple jurisdictions, there are such a large variety of use cases that can impact what type of UAS program you're going to implement. And so when you look at those different use cases and what the requirements may be for each, and what the applicable regulations may be across the board, that's where we've looked at that modeling approach, providing the integration across those use cases, across those requirements, so that as things might change, say, specifically as things are moving forward, like changing with regulations, this system is very dynamic. So if a regulation changed, what are those dependencies across your entire set of operations, and what other changes need to be made across the board based on a change like that?
Very good. So question about autonomous for just a minute, okay? So I attended the Consumer Electronics Show, and one of the sections, I don't know if you guys know this, now, Consumer Electronics Show in Vegas cracks what, 250,000 people, something like that. They take every hotel room in the city, which is saying something. There's a whole section there on autonomous vehicles. The autonomous air vehicles have gotten to the fore because their statement is you can't possibly solve all those problems on the ground that you run into. So you might as well just get up in the air and fly between whatever you're allowed to do, compete with the UAS guys, right, up there. And that's the way we can solve this problem. But at the same time, the autonomous vehicle guys are talking, they're quite proud about the, I think it was 10 million miles or whatever it was that they have tested so far. And what you remember, what is the levels of 1 through 5?
Yeah, 1 through 5.
And 5 is where they got to get to,
yes,
right?
Yes.
In order to be allowed to go autonomously on the, so that the driver like Sandy can sleep on the trip, up there and not worry about it, right? Okay. And I think if I remember right, level 5 takes 2 billion miles, something like that, some outrageous amount.
Yes.
And they were quite proud of their 10 million miles that they had tested so far. Okay. Okay. And of course, I understand you guys get a pretty good job if you want to go out and sit behind a car, and participate in this, if you guys want to do that. But so what you described today was getting the system involved so that it's feeding back information to you. So you're continuously updating. How does that cut the fact that we can get to level 5 faster?
That's an interesting question. Thanks for this. I mean,
because that's what they're going to do. They're going to eventually, they're going to wade their way through it, right?
Yeah, you're right. I mean, we're aiming towards SAE level 5, full autonomy. The human being isn't going to be touching anything. But I feel the biggest challenge is being able to create an intelligent system that can replicate, that is as intelligent as the human being, and being able to perceive, the environment, and being able to react adequately to the environment and make decisions, and actually make the right decisions, because safety, and losses are also part of this equation, and there's a problem with public certification. So it's safety critical, but again, you've also got issues with trustworthiness and public trust being involved. So it's, I would say it's a very careful situation. But one thing I see is, I think systems engineering needs to actually work with, other guys, the computational guys too. I feel like there's a lot of hands on the research, but collaboration is actually key. We need a system that can actually, right now, we're not there yet. I think we are solidly on level 3. Some guys are claiming level 4 already. I'll say comfortably level 3 for now, but if we can have a system that can, we're coming into this digital twin technology of a thing, just being able to, send feedbacks back to the physical system. So if we can get to that level where you have a system, a kind of a replica, in terms of the modeling aspect now, a system that can replicate what the physical system can actually do, and then things like verifying, validating the physical system, it's going to come. I think that will come easily. But right now, that's a challenge. We don't have that, especially with autonomous vehicles right now. We still don't have that. And this is where you get to know, for example, you have a snowy road, for example, we still have some challenges when when they're testing these vehicles, Tesla and all these guys, when they're testing all these vehicles, they still have some, we still have some challenges where we still have some accidents, and, it's like, okay, the system couldn't really perceive this particular situation in the environment. Because if you look at it very well, you're having a system where we're going to be having some requirements that weren't planned for. So how do we handle this at that particular instance? So we have a lot of questions going forward, but I think we're getting there though. It's a very challenging question.
It is. Okay, Perry, there's another question here for you. What's your opinion about the V model? Go ahead. Just remember, there's lots of people out here that may throw things at. Just kidding. I'm just kidding. I'm just kidding.
I might.
So they said maybe for software dominant project, agile. They had a misspelling here. Agile scum can take care of continuous integration, communication. How is this possible for hardware dominant systems? Right?
Could you repeat the last half?
No, the whole process. They're concerned about the fact that how would this work? The V model. How does it? Let me see if I can repeat the whole question for you. Is it still V or what?
Right. Okay. So there are these two views of the world that seem conflicting when you talk about the V cycle, and that's waterfall, agile, and V. And it's only possible to have a V cycle with a waterfall model. And I don't really believe that, but it's a different view of the V to what people are familiar with.
He says that's a Freudian slip. I think it's a misspell. Right,
I don't think it is. So what we've, and again, I'm gonna take a parallel here on what's happened in the software and the gaming and the other industries. And then I'm going to explain what that looks like with the V model. So what's happened in these other industries, you don't try and go end to end with V1. In the software world, what you'll do is you'll build a quick mock-up, a really ugly, crude prototype that gives you a sense for where the issues are. And you'll do that completely sort of in a different thread. You won't try and merge any of that prototype code with the real code. With a video game, you'll build a tech demo. You won't build a game, you'll build something completely different. That's just there to test one or two different elements of it. And that low resolution mock-up then gets binned for something that's a bit more scalable. And what you'll start doing is you'll have one big box, you'll start drawing a square, and you'll have 4 boxes inside of that, and you'll start adding resolution. And this is the model that the software engineering world has come out with, which is a model of taking a thing that's flexible and scalable and iteratively adding resolution, and doing that not over the course of a design review loop in 3 months, but doing it daily. Every single day, you'll have 10, 20, 50 pushes, and you'll push that and you'll have that in an integrated way. So if anything goes wrong, you can always revert back to a baseline. So I think V can exist in the future for systems engineering and for hardware engineering. But I think what we've got to do is we've got to look at the V, and we've got to say, how do we go from the top left of the V to the top right of the V as quickly as possible? And then go down rather than going from left to right, if that makes sense. So how do we go end to end with a really low resolution, a really crude Excel spreadsheet of a rocket, of a launch vehicle? And then how do we iteratively add resolution to that with more and more fidelity, more and more people, digital 0D models to 1D to 3D to physical tests, rather than trying to do this in a stage-gated way. So top to bottom rather than left to right.
Okay, other questions? Otherwise,
I've got a question for you.
Go ahead.
So the S-curve of adoption is interesting. Where do you think Mbsc is on that right now? And then what gets us to the next stage?
I'll give this back to you.
The interesting thing is I presented this to my boss, as a practice, and he had that exact same question. I don't know, honestly, like if you look at the Department of Defense, it's going to be different than if you look at the Air Force or the Navy. Like I happen to know that I'm an Air Force. I work for the Air Force. The Navy's further along than the Air Force, and I believe that some industries are further along than the Department of Defense. I don't think we are I don't think we're in the early majority yet. I think we're hopefully getting close to the early majority. And I don't know, I'd be interested as everyone saw the presentation, saw that curve, to get anyone else's input, because I just don't know, but I don't think that I don't think we've crossed the chasm yet, so to speak, to where that this is just what we do. We are not talking about an Mbsc initiative. We're just talking about, hey, how can we do it better? It's going to be like everything else that we're doing in systems engineering. So I've thought about it and don't have a great answer for you yet.
Thanks.
Do you have a question?
I do. Well, and I'll add to that because I agree with you completely. And I think the other challenge is that it's so pocketed the way that it's being implemented. So even just at my organization, it'd be hard for me to say where we are on that curve because I've got parts, they've adopted it, and other parts who can barely spell Mbsc, right? And so we're not anywhere near that chasm. And to me, I think we'll be over the chasm when this has been said for years in this forum, actually. It'll be nice when we get to the point where we don't see Mbsc anymore. It's just how we do systems engineering, right? So that's the nirvana. But my question was back on the AI topic. Because we started talking about the different levels and at what point, autonomy becomes acceptable because it's safe enough. So interestingly, we had a strategy session yesterday talking about ethics in systems engineering. We talked about a broad scope of ethics, but AI did come up, of course. And so I was curious if there's any discussion about, or if you had any thoughts about the idea of modeling, adding ethics into your model with regard to how decisions get made and those, the examples of the difficult decisions if the car has to decide whether to crash here and kill one person or there and kill whatever, those kinds of things. Is that modelable? Or how would you factor something like that in?
Actually, I've thought about this before. And to be honest, I haven't been involved in a lot of work in that area, especially when you're talking about ethics and you're talking about, policy and decision making. I mean, with regards to that, because that's what's going to bring the solutions to the market. That's what is, if you're talking about commercialization as a future goal, that's where we need to get to. I mean, before all of this can even happen. So we can test millions of miles and keep testing, but if we don't resolve what you've just said, we're going nowhere. I mean, if things like VMV for this kind of systems aren't gotten right, we're going nowhere on this thing. So I believe that's like that's another step that should be considered while we're doing all of this. Not a lot. I haven't seen a lot. I haven't seen substantial work being done in that area, to be very honest with you. It's more of how can we get this system to do this, do that. But again, we need to get to that, that ethics aspect of things and ask ourselves the questions. I mean, what level of, autonomy? I mean, can we allow vehicles to do certain things? I mean, are we okay with a certain threshold of, fatality rate or, crashes or stuff like that? These are open questions that I think we need to start getting into. I mean, simultaneously with what we're doing right now, but again, we're not there yet, but I think that's the next step, to be honest with you.
So I'm not an expert. This is just a comment, and I guess I can make it since I'm standing here next to you. But I look at you guys in this field, and it's a tough question you're being asked, right? Because we allow 16-year-olds to get behind the wheel, right? And we're not asking, that 16-year-old to make it like to define, okay, if you have to decide to kill this kid or this kid, which one are you going to do? So yeah, kudos to you guys in this world. And I know it's not your specific interest, but we have a higher standard for our machines than we do for our people behind the wheel.
Yeah, I mean, thank you so much for what you just said now, because again, I remember someone asked me the similar question and I was like, honestly, you're right. Because I mean, if we don't have this, very tough, restrictions and, specifications for 16-year-olds and, 15-year-olds on the wheel. So, I mean, why can't we cut our machines, that slack and, give them a little bit of tolerance, but again, the general feeling is like, no, we don't, I mean, I don't think I'm feeling that. But again, to be honest with ourselves, if we look back, I mean, maybe we might just get to the point where we start thinking like that. I mean, because it's a tough question, as you said. Exactly, because I mean, you have to look at the goal, right? Okay, if you use an AI, I mean, if you're with a self-driving car like level 5, as long as you look at the data and the fatality and the crashes rate, they're lower, way lower than if human beings were driving, then I think that's good. I mean, that's good. But right now, it seems we're striving towards perfection, and I don't know if we're gonna get there. I don't know.
Okay. Step up the microphone. I know you can't just not sit there and do it. That's right.
Yeah.
Go ahead, Cynthia.
So respectfully, in that example, though, we're in a different system when we go to AI level 5 cars. If there are the majority of AI level 5 cars, a human or a 15-year-old wouldn't be as effective there. So that would be too low of a bar, right? It would be different. We're talking about two different systems once we have these cars.
Yeah. I just want to, I'm trying to create an analogy over here. Because sometimes when we're talking of requirements, right? I mean, we're thinking of, okay, we kind of have a hang on this requirement. The system must do this, based on certain scenarios. We have some scenarios, but the question is, we're looking at a problem where, I mean, the systems you're trying to create, these AI-enabled systems you're trying to create are going to be, when they start operating within the environment, they're going to be dealing with scenarios that we likely did not plan for. So as a human being, I mean, we have the ability to think through and decide at that moment on what to do. Our machines are going to be facing the same situation. And it's a question of, for a scenario that has never been created, that wasn't even in part of what was modeled, how's our, autonomous system going to handle this situation? So these are the tough questions because this generates new requirements if you look at it. And if we don't have that on ground right now. So how do we create machines that can actually handle this? Again, I mean, if we're looking at the problem, we have to be looking at things like this too, because that's the reality.
Got a question?
Question and comment, and sorry, you've got to keep the microphone.
You got a comment with the question? Okay.
So bringing it back to Mbsc for a minute, we're talking about the ethics of autonomous vehicles, and that really what we're talking about is assumption of liability. When the 16-year-old is behind the wheel, the 16-year-old is liable for his actions, and nominally his parents might be liable for his actions too. But when the autonomous vehicle is involved, who is liable for its actions? We are a country of liability. We have insurance. We have all this legal structure around who pays when something goes wrong. And I would argue that the modeling, the holistic approach to how we develop a system is not just technical. We need to deal with the policy side of things and the institutions around it that deal with things like liability. And any comments?
Thank you so much on this question. I don't know if we remember something that happened last year. There was an accident with a Tesla vehicle in Texas. The vehicle was trying to negotiate a curve and it rammed into a tree, killing the two people in the vehicle. And it was a question of who is to blame, who is liable for this. Next thing, they tried pushing it on Tesla. Of course, Tesla said nope. These guys who were driving the vehicles, God bless their souls. They weren't using the free self-driving module of the vehicle. So you can't blame us for this. They were at the steering wheel because it was a matter of was one of the human beings, the passengers in this vehicle, was the driver controlling the vehicle at that point, or were they, using the self-driving module? But again, I'm just trying to use that experience because when I looked at what happened, they were just trying to push the blame. So you're right. I think we need to the policy aspect is very important because these are things that contribute to the low level of public trust in all this kind of technologies, because when an accident happens, who do we push the blame on? I'm just giving you an example. At the end of the day, of course, Tesla won because they were able to, if you can prove that, something wasn't on or they weren't using the self-driving technology, then, we can easily blame those driving that, okay, someone was driving this vehicle and that's why we have this. So again, yeah, these are real questions, and the policy, I think the policy questions too should be really focused upon.
So you didn't see the movie I, Robot or Runaway? Yeah. So that's why we're, okay, one other question here, and I guess we can consider it. Perry and I were having a conversation out in the hallway, and Perry asked me, should we just give up? I think that's a good way to put it, right?
I would have put it that way.
Well, should we just give up and just, let it go, and or should we continue to try to do this? Because there's lots of things preventing. As I described to Perry, we have this problem of complex products. Just the product itself is complex. And then the product itself is being developed within a complex system of a business. And that business, of course, is operating inside of a complex world. And so there's all kinds of interesting cultural interactions that go on. For example, I remember in the EE world that there was a legal review of our design to evaluate the liability of this product before we continued, right? Okay. Even though it was a cool product, there was this legal review that could veto that, right? Okay. So that's the kind of things that you have to deal with and so forth. So on, the question is whether you want to design yourself for liability. I'll use that word. You got the design for X, design for whatever. Do you want to design yourself for liability to minimize your risk exposure of liability and stuff like that? That's out there. Question then was, the Perry and I were talking about was, okay, do we continue or try to do this thing, or do we just live with the experience or whatever, right? So I'll let Perry give his answer. I can give my answer when he's done, I guess. What I think.
Yeah. So it's a question about how much pain you're willing to endure, I guess, before we get there. I think there's a general consensus, and I think everyone in the room is for sure going to agree that we're going to get there. It's a matter of truth and a matter of progress that's happened in every other field, and we're going to be no different. So then comes the question as to why has it happened in other industries, and why is it taking so long in ours? The gaming industry is there with the advent of game engines like Unreal Engine and Unity. The chip design industry is there. They've got VHDL, Verilog, Synopsys, Cadence. The software engineering for sure is there. And I think it comes down to, and this is painful, external factors that drive demand, that drive an iteration speed, which drive the adoption of better tools, which is to say, if people want phones, they want chips. If people want chips, they want faster chips. If companies need to ship faster chips, there's no way they're going to be able to do it by drawing pen and paper. And I think I'm very optimistic about this, because we're now entering this new phase of engineering where we have 3D printing, where we have a mass economy which is asking for more vehicles and more hardware and more from us at faster speeds. Just look at what's happened in EVs. Look at what's happened in new space. Look at what's happening in new aerospace. This transition is happening. So I guess my real question is, this is happening, and it's happening with the new age companies. And my question is really around, how are we going to transfer that culture and that speed and those processes that are happening in the new age companies to Boeing and to Airbus and to these massive scale companies that need systems engineering the most, ironically enough. How that happens, I don't know.
So the quote I shared in my presentation by Griffin, the name of that paper or the conference that he gave that in was "How do we fix systems engineering?" Recognizing that, yeah, we can have all the technical solutions all day, and it's not the technical problem, right? It still comes back to, we have to trust that our CEOs and our chief engineers and everyone up and down the line who's involved with developing these systems doesn't want to throw away 50% of their budget, schedule, everything. So we need to go beyond just showing, hey, it's going to cost you less, it's going to go faster if you go model-based, because obviously that's not enough. We have to understand human behavior to a deeper level to understand why they're making that choice. Because, you know, from the 10,000 foot view, it's not a rational choice, but, you know, we're assuming they're being rational. So let's look more at things like diffusion of innovation theory, some of these other cognitive psychology ideas, choice modeling, those types of things. And I think it's good to come from within the systems engineering community. if we turn to psychology and just throw it over the fence and be like, hey, fix us, we're not going to listen to that, right? Because we're engineers and we know what to do. And so I think that within the systems engineering community, we have a great opportunity to go outside of our field a little bit, pull those things in and fix it from the inside instead of turning out. But it is a human behavior problem, and we need to understand human behavior to understand that.
Yeah, very good. That's probably a good place to end it. Excellently said. So if we can give these guys an audience, thank you. Thank you all. Okay. So we're wrapping up today, but I want to point out to you what's on the docket tomorrow. Tomorrow morning, I'll give you a little background as we go. Tomorrow morning, Sandy Friedethal is here. So he's up first to give us an update on System LV2. Sometime during the week, he's probably going to talk about that there's a couple of sessions on V2 prototypes that are available for demonstration here at the workshop that you guys need to make sure you take a look at and participate in that review with them. V2 is after solving the communication problem. You have a communication problem. Those of you that are, you do, okay? Like what's the movie? Cool Hand Luke, okay? Okay. The issue's got to do with the fact that today you can't share a SysML model with others without a lot of work, okay? So that's one of the communication problems we have to go solve, and the V2 is about solving that problem. So I think it's important that you go spend some time with that. We'll have the working group round robin that's going on. This is various working groups want to report into you about Mbse activities that they're performing that are doing. It includes like the digital exchange, interchange working group, others that are out there. The resilient systems guys want to be here and talk to you and so forth. So that's on for tomorrow. Now that's the question. We often get a call, email from somebody who says, I want to join and be a member of the Mbse initiative. The Mbse initiative is a hub of trying to communicate between everybody, because it's not like Mbse is any one thing, right? It goes throughout. In fact, Eric Herzog regaled us about you guys are with our propeller hats in the basement kind of thing, and says you guys need to spread it out, and it's spread out all by itself, okay? There's system models in almost every working group, and they want to share with you what they're doing. So they'll be here to talk to you guys tomorrow in what they call a round robin. We have an update from the DoD on their digital modernization efforts, also from CERC. We have an analyst representative that will be here with us tomorrow. All the various analysts, SimData, Gartner, so forth and so on. You guys will remember we had Gartner here a couple of years ago talk to us about it and why it's important, systems engineering and so forth. They'll be here to talk to us tomorrow. This guys will be from SimData, will be here to talk to us tomorrow. Then we're going to do an update on all the various standards that are going on. There's lots of system engineering standards happening that you guys need to be aware of, like 14641, which is a standard systems engineering methodology. It's ISO standard that's going through the process right now. If you want to see, what's the word? The exchanges that got people angry inside of here talking about methodologies, then that's an interesting one you may want to attend. We also have the tools database guys showing up here to give you an update on what they're up to doing. The tools database at one time had some 5,000 tools in it, and various graduate schools, one of the requirements was that they contribute to a tool and that's why it grew pretty good size. It's back up to 300 now. When we upgraded technologies, we lost it. Okay, and now it's back, and they're in process of building it. Dr. Austin will be here to talk about AI. There's a system engineering working group in AI, and OSLC is going to be here as well to talk to us about that. At that point, we will have exhausted everybody. We've drawn the limit at 2 days, what we can pack into that, and we'll have our propeller hat awards and our social, so you guys can blow off and drink all the beer you want. I know you guys are big party animals, like all systems engineers are. So if there's no further questions for today, we'll get back together at 9 o'clock in the morning following the opening plenary, which is going to be talking about they're announcing the vision, right, Paul? So you want to be there for that as well, because one of the major sections is model-based systems engineering. Okay, so with that, we'll call it a day and say thank you all for being here. Thanks everybody for participating today. It was an excellent day. Let's have a follow clap for everybody here. And we will sign off for today. Thank you, guys.